So we have this bounded region and we want to revolve the bounded region, revolve it around the line y equal to negative 2. So this is the graph right here for x equal to the square root of 8 minus y. This is the line y equal to 0, and this is our bounded region. And we want to revolve this bounded region around the line y equal to negative 2. So this is the shell corresponding to this rectangle right here. The average radius will be the distance from the axis of revolution to the center of the shell. This is the y, this is the x-axis right here. And so from here to here, from the y-axis to the center of the shell is some y distance. So this is some y distance. And then we also have from here to here, which is a distance of 2. And therefore the average radius will be y plus 2. Or we could also write it as y minus negative 2, which is the same as y plus 2. The height of the cylinder would be just the graph minus the y-axis. So it would be the graph is x equal to the square root of 8, and then this is the line x equal to 0. And so it would be the square root of 8 minus y is the height of the cylinder, of the shell. And notice that y ranges from y equal to 0 up to y equal to 8. And so for our limits of integration, it would be from 0 to 8. And so to set up the integral, to get the volume of the solid of revolution, the average radius will be y plus 2. The height is the square root of 8 minus y, and then the thickness is dy. And to integrate something like this, we can split it up like this. So this is y times the square root of 8 minus y plus 2 times the square root of 8 minus y. And then we have to integrate this part and this part individually. So let's go ahead and see how we find the antiderivative for this part. And so to do this integral right here, we can use what's called U substitution method. So let U be 8 minus y. And then solve for y. We get y equal to 8 minus u. The derivative dy of y with respect to u, or dy du, this is 0, this is negative 1. And so the differential dy is equal to negative 1 du. And y is 8 minus u. This is u, and so this is the square root of u. Dy is negative 1 du. And then we can put this negative 1 out in front. The square root of u is the same as u to the 1/2. 8 times u to the 1/2 is 8u to the 1/2. U times u to the 1/2 is u to the 3/2. Antiderivative of u to the 1/2 is add 1 to the exponent. 1/2 plus 1 is 3/2, and then dividing by 3/2. 3/2 plus 1 is 5/2, and dividing by 5/2. But u is 8 minus y, and so we'll replace u with 8 minus y. 8 divided by 3/2 is 16/3. And we have a -1, so that becomes negative. And dividing by 5/2 is the same as multiplying by 2/5. And this is -1 and negative here, so we end up with positive. So the integral of y square root of a minus y is this. And so now we have this integral is this. That's what we just found. And then we'll evaluate from 0 to 8. And now let's go do this integral. The integral of the square root of 8 minus y. And to do the integral of the square root of 8 minus y, we'll also use the u substitution method. So let u be 8 minus y, and then solve for y. We get y equal to 8 minus u. And then find the derivative of y with respect to u. Derivative for 8 is 0. Derivative for u is -1. And then the differential dy is equal to -1 du. So 8 minus y is u. dy is -1 du. The square root of u is the same as u to the 1/2. Antiderivative for u to the 1/2, add 1 to the exponent. 1/2 plus 1 is 3/2. Dividing by 3/2. Dividing by 3/2 is the same as multiplying by 2/3, and then we have a -1. But u is 8 minus y, so we end up with -2/3 times 8 minus y to the 3/2. And now, so here we got 2 pi times 4, which is 4 pi. And we just did this integral, which is -2/3 times 8 minus y to the 3/2. And so now we evaluate from 0 to 8. So we plugged in an 8 in here, and plugged in 8, and of course it would be 0 and 0. And then we'll plug in 0 and 0. So this part will be 0 because it's going to be 0 here and 0 here. And so all we have left is this. So when we plug in 0 here, we get 8 and we get 8. And this part is 0. And so this is what's left, which is right here. And then for this part, if we plug 8 in here, then we get 0 right here. And then if we plugged in 0, then we get 8. So this is from this integral. And so here you have 0, so this part is 0. And then minus and minus will become positive, will become plus. And all of this will come out to be 492.86381. So the volume of the solid of revolution is 492.86361.